Modulation. Limitations of baseband transmission are overcome by using modulation. Now, what is modulation? Modulation is the process of varying one or more properties like amplitude, phase and frequency of the carrier signal in accordance with the modulating signal, which typically contains information to be transmitted. Animation shows how exactly the modulation takes place. Let's consider message signal or information signal, that is small m of t, and the carrier signal, that is high frequency signal, denoted as small c of t. Both the signal is transmitted through a modulator, in which the parameters like amplitude, phase or frequency of signal carrier c of t changes according to modulating signal, and at the output we will get the modulated signal capital M of t. Now let's take a look on why do we need modulation. To achieve the following requirements, modulation makes multiplexing possible. That means two or more signals can be transmitted over a channel simultaneously without getting mixed with each other. Due to this, interference of noise is reduced. It is possible to achieve better quality of reception by reducing the noise interference. Modulation increases the range of communication. More importantly, modulation helps in reducing the height of antenna, which we will discuss in detail in further animation. Now, let's see how modulation helps in reducing the height of antenna. Suppose we want to transmit electrical signal having frequency of 20 kHz, which is voice frequency over an antenna. But there is one more difficulty in this process. It is necessary to keep antenna height equal to the wavelength of electrical signal. Wavelength is equal to velocity of electrical signal upon its frequency. That is, lambda is equal to V upon F. For example, assume frequency to be transmitted is equal to 3 kHz with velocity of light. Thus, wavelength obtained is 100 km as shown in the animation. Then, the height of antenna is equal to 100 km. This height is practically impossible to implement. But after modulation, frequency is increased, which is equal to 3 MHz. Then, by calculating, we get 100 meter as height of antenna, which can be easily constructed. Demodulation. Demodulation is the process of reconstruction of original baseband signal at the receiver. That is, extracting the original information bearing signal from a modulated carrier wave. A demodulator is an electronic circuit that is used to recover the information from the modulated carrier wave. As shown in the animation, the modulated signal is passed through demodulator, which consists of rectifier and filter. Rectifier passes the current only in one direction. Filter filters out unwanted signal, and at the output we will get the original information signal as shown in the animation. Now let's discuss various types of modulation. Modulation is mainly divided into two parts, that is, continuous modulation and pulse modulation. Continuous modulation is again divided into two types, that is, amplitude modulation and angle modulation. Amplitude modulation is divided into four types, that is, double sideband full carrier DSBFC, double sideband suppressed carrier DSBSC, single sideband SSB, and vestigial sideband VSB. Angle modulation is further divided into two types, that is, frequency modulation and phase modulation. Now let's see the second type of modulation, that is, pulse modulation. It is divided into two parts, that is, analog pulse modulation and digital pulse modulation. Analog pulse modulation is again divided into pulse amplitude modulation PAM and pulse time modulation PTM. The pulse time modulation is again divided into two types, that is pulse width modulation PWM and pulse position modulation PPM. Digital pulse modulation is again divided into four types, that is pulse code modulation PCM, differential pulse code modulation DPCM, delta modulation and adaptive delta modulation ADM. All these types we will discuss in detail in further animation.